Hello Mathies, Gatos here. In this video we are going to look at what do we do with polynomials in the form x squared plus bx plus c. Well, in the last lesson we looked at how to multiply with tiles. So we would do an example, this was one of our examples where we did x plus 2 multiplied by x plus 1. So when we went in this direction here, we were multiplying. So x plus 2 times x plus 1, when I multiply, the answer is x squared plus 3x plus 1. In this video, I want to look at how do I go backwards. So how do I go backwards if I have x squared plus 3x plus 2 into its factors, x plus 2 and x plus 1. So let's look at how do we factor with tiles. So in the last video when we were multiplying, I gave you the length and the width and you had to figure out the area. This time I'm going to give you the area and you have to piece them together. It's kind of like a little puzzle into a rectangle and find the length and the width. And those will be the factors. So let's start with something like this. I have x squared plus 8x plus 7. So what I want to do is come up with how that's going to look as a whole polynomial. So I have an x squared and I'm going to have 8x pieces. Now remember, we can flip these around into any way that we want. So there is 8x's. And then I have 7 positive 1s. So what I want to do, and this is where we have to do our puzzles, is I want to place that together in the shape of a rectangle. Okay, so I know I have my x squared, and then I have these x pieces that I'm going to piece together. So I want to try and fit them together so that they fit like a rectangle. So if I start like layering these, see what I can kind of come up with. I can see, okay, I've got my 1s tiles. Now I can't fit those 1s tiles into, because 7 doesn't fit into a nice little square or rectangle, so I'm going to just try them as like 7 individuals. So if I do that, I'm going to label all of these in here, so trying to line it up as best as I can. What we're trying to do is fit it together in a shape of a big rectangle. So I think I might be onto something. Yeah, that looks good. Now this guy will fit right there. I just have to rotate him though, so he fits like that. Ah, there we go. So it's just like putting a puzzle piece together. So that fits together into a total rectangle, which measures x by 1, 2, 3, 4, 5, 6, 7. So x plus 7 over here. And then along here, I have x plus that little 1. So what that means is that x squared plus 8x plus 7 is equal to x plus 1 times x plus 7. Now we could apply the distributive property twice, a little double rainbow, to actually check if that is right. So here I have x squared, I have 7x, I have 1x, and I have 7. So grouping my middle terms here, plus 8x plus 7. And it looks like, yes, in fact, I have done that correctly. Okay, let's try another one. So in this one here, I have x squared plus 5x plus 4. So I'll take out my x squared, and then I have 5 x's, and I have 4 1s. So again, I want to kind of piece these together. Honestly, when I look at this, I use my 1s tiles to kind of help me come up with what my factors are going to be like. So if I look at my 4 1s, I could do like a 2 by 2, or I could do all 4 of them in a row. So if I went back to a 2 by 2, watch what would happen. I would have 2 here, and then I could take these 2 here, rotate them, and fit them along the side here, but then I'd have this one guy left over. So it doesn't look like a 2 by 2 will work. So let's try it as just a string of 1s. So I'm going to have 1, 2, 3, and 4. So then my x tiles will fit together. And then again, it looks like I can just rotate that one and put it in here. So I like working with the tiles because it's just like a jigsaw puzzle, like kind of fitting things together. So along here I have x plus 1, 2, 3, 4 1s. Along here I have x plus just 1. So x squared plus 5x plus 4 factors as x plus 4 times x plus 1. Now factoring just means multiplying it by something a little bit simpler. But again, I can always check, which I always like to check just to kind of see if I'm on the right track. So I'm going to apply the distributive property twice here, group my like terms, and I have the right answer. So it looks like I did that correctly. So let's put this together here and see if we can come up with some sort of a pattern. So I have the two polynomials I just did plus the polynomial of the last lesson, and I want to see if I see some patterns between a polynomial and its factors. So basically, I'm trying to find out a pattern as how to go from here just to that straight away. So I see a bunch of patterns actually. Let's just use some colors here. So I see that x squared, they all start with x squared. And notice that the first number in each set of brackets is x. Well, that's because x times x is x. So that's my first pattern. Then I see another pattern. I see the pattern with my ones digit. So see how I have a 2, a 7, and a 4? Look at the last parts of my brackets. 2 times 1 is 2. 7 and 1. 7 times 1 is 7. 1 times 4. 1 times 4 is 4. So it looks like the first the first terms in each bracket, x, because x times x is x squared. The last two numbers in each bracket is the product of my end term. Well, how does that tie to my middle term? Well, let's look. If I look at my middle term, 3x, what am I doing with these numbers here to get a 3? Well, I see right here that 2 plus 1 is 3. Let's look at the 8x. 7 plus 1 is 8. 5. Let's add those two together. Ooh, 1 plus 4 is 5. So it looks like I've come up with a little pattern here. So the first two numbers are my first term, the product. The product of my last two numbers is the last term in my polynomial. And if I take those numbers and add them, I get the middle term. Well, I can use those patterns to then factor polynomials. So x squared plus bx plus c. We're going to factor this with product sum. So it's called product sum because we're trying to find two numbers that multiply, there's the product, to your c value, which is what we saw, and add to your b value, which is your number in the middle. That's the exact pattern that we found. Once we found those two numbers, we can just go ahead and factor with brackets. So x in the first one, and then my factor pairs as the last two numbers. So the trick really to factoring these polynomials with product sum is actually finding the factor pairs. So to find factor pairs, you can use your own number sense to do factor pairs, but there is a way to help you on the calculator find those pairs. So if I want to find two numbers that multiply to your c, which is your last value, and add to b, which is the number in front of x, you can go into your y equals and enter this equation in. C, whatever that number is, divided by x. Once you've done that, you can go into your table and look at all your whole number factors of c. I only want whole number factors. Actually, I'm going to change that to integer factors because it could be a negative as well. But what I really mean by this is no decimals or fractions. So you're going to try and find the integer factors of c. You're going to look at all of those integer factors, find that one special pair that also adds to your b value. So let's try an example together. So I want to find two numbers that multiply to negative 12 and add to positive 1. So since I'm looking for ones that multiply to negative 12, in y1, I'm going to enter in negative 12 times x. Now you guys might already know what that is, and that's awesome, but I want to show you on the calculator in case you're ever stuck. So I'm looking for factor pairs of negative 12 that add my magic sum to 1. So in my calculator, I go into my y equals. I enter in negative 12 divided by x. And then I want to go into my table, which is right above graph, so second graph. Now in here are all the factor pairs of 12. So I'm looking for the integer pairs, so 1 times negative 12. If I add those, I would get negative 11, so that's not what we're looking for. My next one, 2 and negative 6, multiply to negative 12, but they add to negative 4, not what I'm looking for. 3 and -4. That multiplies to -12, but it adds to -1. And I'm looking for the factor pair that adds to +1. So I can see that this is it right here. 4 times -3 is -12. And if I add them, it's +1. So looking here, my factor pairs are -3 and +4 in any order. -3 and +4. So I would use those factor pairs to factor the trinomial. So now that we've practiced factor pairs, let's go over here and do the whole thing in factoring. So factor x squared plus 8x plus 15. So I am looking for two numbers that multiply to +15 and add to +8. So two numbers. So think about all the factors of 15. You can list them out. You can go into your table. I'm looking for the magic one that multiplies to 15 but also adds to 8. So I know that it is 5 and 3. I can even add in the positives if you like. +5, +3. So here's how I go ahead and factor it. So x goes in my first term of the brackets, and then +5 and +3 in any order. So that would be okay, or I could switch them around. Well, if this is what x squared plus 8x plus 15 equals as a factorization, let's just check that to see if I'm right. I love this. I can check everything that I'm doing just to see if I've done it correctly. And I do recommend that you do that. I'm a big fan of the check. Okay, add that together. So grouping my like terms here, 3x's and 5x's are 8x's plus 15, and that's what I wanted. So that polynomial is factored. So I want you guys to move on and do some factorization. Happy factorization, happy teacher. So I hope that this video helped, and I look forward to seeing you for the next one.